Let's understand valence shell electron pair repulsion, VSEPR. Now, in case of valence shell electron repulsion, what we find is all about sp3 hybridization. In case of sp3 hybridization, we know that the bond angle comes to 109 degree, 109 degree, 109 degree, 109 degree. Though I would be representing just one bond angle. Alright, so but we are aware that those bond angles are applicable for all bond angles in that particular molecule. Alright, so now here what we find is, in case of sp3 hybridization, the bond angle is 109. We have seen methane and we have observed that the bond angle is 109 degree. But then what we observe is, in case of ammonia, NH3, in case of water, OHH, that is H2O, the bond angle is 107 degree, so it does not follow sp3 hybridization. And then here it strays away further. It comes to 104 degree. Now why does this happen? Let's try and understand. Now in this case, sp3, whenever we talk about sp3 hybridization, that itself means there has to be 4 groups attached. Why? Because 1 of S and 3 of P. So 1, 2, 3, 4. Yes, it is sp3 hybridization. And the bond angle 109. Now when we come to ammonia, we find that ammonia has got 3 groups attached. Ammonia has got 3 groups attached to it. And the fourth, instead of fourth group, there is lone pair, electron cloud of lone pair. Now again come to water. In case of water, again it has got 2 groups attached. Here there are 4 groups attached, where 3 groups attached, and here we have just 2 groups attached and 2 lone pair. So what does these lone pair do in VSEPR? What happens here is, now this lone pair of nitrogen repels the bond pair. These are bond pair. Why? Because it is about bond between nitrogen and hydrogen, nitrogen and hydrogen, and nitrogen and hydrogen. So these electron pair repels these bond pairs, and these bond pairs in return repels these bond pair. But the repulsion owing to lone pair, bond pair, lone pair, bond pair is much superior to that of repulsion between bond pair, bond pair. This repulsion which is there is much weaker in comparison to this repulsion. So this is lone pair, bond pair repulsion, lone pair, bond pair repulsion, and this is bond pair repulsion. So the bond angle, instead of being 109, moves down to 107 degree. Alright, now coming to water, we have 2 lone pairs. So there is lone pair repulsion, which is very strong. And then there is lone pair, bond pair repulsion, lone pair, bond pair repulsion, and there is also bond pair repulsion. Now lone pair repulsion is very strong. Lone pair, bond pair repulsion is slightly weaker than lone pair repulsion. In comparison to all this, bond pair repulsion is pretty low. So there is no other choice but for the bond angle to reduce to 104 degree. This is the reason why, in spite of all 3 being sp3 hybridization, here the bond angle is okay because there is no lone pair present for generating lone pair, bond pair repulsion. In case of ammonia, there is 1 lone pair which is generating lone pair, bond pair repulsion, and in this case there are 2 lone pair. So lone pair, so it has got not only lone pair, bond pair repulsion, but it also has lone pair repulsion. Alright. So in conclusion, we can say that lone pair repulsion is greater than lone pair, bond pair repulsion, which is greater than bond pair repulsion. Why is lone pair repulsion maximum? It's maximum because it is repulsion between 2 electron clouds, negatively charged electron cloud. So LP is sitting at the top of the series. So That's the reason why the bond angle, in spite of these two also being sp3 hybridization, the bond angle reduces. And this is what is we call as valence shell electron pair repulsion.